Okay, on this, we're gonna pick up with unusual events, and what we consider to be unusual events versus, I guess, expected events. So an unusual event is one that's not likely to happen. Um, Basically, the probability would be extremely low for this to happen. Now, there are no set in stone rules for this. The general rule is if it's 0.05 or 5% or less, we consider it unusual. In some circumstances, we may have to move that line around. For example, if we were talking about probability of getting childhood disease, particular childhood diseases, and if one of them was, 0.05 and another one was 0.05, and then we saw a break and it went down to 0.03, 0.02, 0.02, we might separate the line a little bit under 0.05 for that one. So they asked in a college of 5,000 students, 150 of them are math majors. A student is selected at random. It turns out to be a math major. Would this be considered unusual? So we set this up as 150 out of 5,000, which is 0.03. This is underneath the 0.05 rule that we generally use. So that would be considered unusual. Okay. So we're going to take a look here at problem number 8. Okay. Out of take that back. I'm going to go one more slide. Okay. So this is going to be empirical method. Basically, with the empirical method, it is driven. So whatever our data says, that's what we're going to use. Now, it's still going to feel very much like the traditional method. The difference here is I don't know how many things are going to be in it. So I have to go off of the data, and I do not assume that anything is fair. I don't assume that anything is equally likely, anything of that nature, okay? So we're going to take a look at some examples here. We're going to start with number 7. So it says a coin is tossed 400 times. It lands on heads 184 times. Use the empirical method to approximate the probability that comes up heads. Now let's do the same setup. I'm going to do 184 out of 400, okay, which in its decimal form is 0.46. And again, you could do the math inner trick to get that to convert over to a reduced fraction if needed. Okay. Now, the next one is it's talking about the number of children. Okay, I'm going to quickly get this down. Okay. So they do tell us that we have a grand total of 46,068. Okay. So the first question they ask is, what's the probability of having 5 children? So we're going to look, line 5 has 1819 out of our 46,068. Okay. Its reduced form, or in its decimal form, I got 0395. And that was rounded to 4 decimal places. Okay. So they ask, what's the probability that a sample one has 3 or more children? So I'm going to go in and I'm going to add these that have the dots by them. Okay. So we're going to add those all up. excuse me, more than 3. Let me get rid of this one. I misread. More than 3, so that's going to be starting at 4. And we're going to add up. So we're doing the probability of more than 3. Okay. When we add all these up, we get 7826. Again, out of our 46068. That is 0.1699 for that one. Okay. So looking at, now I'm going to get rid of those. It says, assume that this is a simple random sample of US women, okay, which means everybody has equally a chance of getting selected, so nobody's got more chances. Use the empirical method to estimate that they have more than 7. Okay, more than 7 is just going to be this last category, so that's 779. Got one extra 7 in there. Okay, and again, rounded at 3 decimal places. It's 0.0169. Now, it says using a cutoff of 0.05, is it unusual for a woman to have no children? So the first thing is we're going to say, let's figure this out. So this is 12,550 out of our 46068. This is 0.2724 when it's divided. No, it's not unusual. Okay, because this value is more than 0.05. Now, looking back one set, would more than 7 children be considered unusual? Yes, because this is less than that 0.05.